Okay, so welcome to the first video in the A-level lecture series. I hope you'll go on to derive a lot of benefit from these videos which I'm going to create for you. As you know, the course is split up into different parts. You can think of them as different modules, and we're going to start off with the first of them today. I've decided to begin with algebra, since algebra is essential to almost every aspect of mathematics, whether it's calculus, mechanics, statistics, geometry, you name it, they all require algebra. So it makes sense to start off with that first. Algebra itself is going to be split up into different mini-modules, and we're not going to cover all of them one after the other sequentially. Instead, what we'll do is, we'll do one or two of them and then move on to another module, and return later to tackle the more difficult parts which we left out as your skills of mathematics has increased. This first sub-module contains 12 algebra topics. This video and the next one will deal with the first of them, indices laws. And indices laws, I'm going to say there's 5 laws. I'll give 2 of them in this video, along with a general introduction of indices and why we have them, and why they're so useful. That's the general intro done. Now let's move on to the actual content. Okay, so now let's take a look at something like this. Here we've got 6 x's, all multiplied together. Let's say we want to multiply all of this by x. We'll have to write all those x's out again, one by one, and as you can see, it can get pretty boring. Wouldn't it be nice if we had some shorthand way of writing all those x's? That's where indices come in. Indices allow us to represent certain variables, like x, which are multiplied by themselves a certain number of times in a nice, compact way. How do we do this? Well, we identify the 2 important pieces of information, namely that the variable that's being multiplied by itself is x, and that there are 6 of them. So now we have the information. How do we combine them? We could go ahead and say 6x, but that doesn't help us much, since in algebra, 6x is reserved to mean that we have 6 x's, all of which are added together. Instead, what we do is, we write the x with the number 6 superscripted to it, like so. This is an example of an indice. It means there are 6 x's, all of which are multiplied together. This is read as x to the power 6. It's the variable, x, to the power of the number of times it's multiplied by itself, which in this case is 6. Let's take a look at another example. Say we've got a times a times a times a times a. 5 a's all multiplied together. We use what we've learned and say, okay, our variable is a, and there are 5 of them, and they all multiply together. So we go ahead and write a to the power 5. Another example, we have b times b times b times b. Our variable is b. There are 4 of them, all multiplied together, so we go ahead and write that is b to the power 4. There are 2 semi-special cases and 1 special case that we've got to know about. The 2 semi-special cases are x to the power 2 and x to the power 3, and the special one is x to the power 0. Now, looking at the previous 2, x to the power 2 and x to the power 3. In indices, whenever a variable is raised to the power 2 or 3, we have a special way of referring to them. We don't say x to the power 2 or x to the power 3. Instead, we say x squared and x cubed respectively. Now the reason for this isn't important, but I'm going to throw it out at you anyway. The reason for this is a square represents a planar object in 2 dimensions, while a cube is traditionally associated with 3 dimensions. Since x squared is essentially 2 values, 2 equal values, and that's important, 2 equal values multiplied together, the result is the exact same as the area of a square whose lengths are equal to the value of x. Similarly, with x cubed, it's essentially 3 equal values multiplied together, which give you a result which is equal to the volume of a cube of the same length as x. If that confused you, don't worry. You can listen to it again until you understand it, or you can just move on ahead. It's not that important. It's just an interesting aside. Other than that, there is nothing else interesting about x squared and x cubed, which is why they're semi-special. They've just got a special name. The next one though, this one's a little more problematic, and we're going to have to look at it in more detail. You see, the problem with this one is, it doesn't quite fit into the way we've been thinking about indices. For example, x cubed means we've got 3 x's all multiplied together. Let's say x equals 2. In that case, x cubed is the same as 2 cubed, which is 2 times 2 times 2, which is 8. Or let's take b squared, which means we've got 2 b's multiplied together. So if b is 8, we've got 8 squared, which is 64. Now if you try to use the same principle with x to the power naught, we get the wrong answer. If we were to go ahead and say x to the power naught means we've got no x's, and if we've got no x's, then we obviously can't times it by itself, so we've got nothing. Therefore x to the power naught equals naught. But that's not correct. Turns out this beast is actually equal to 1, not 0. Yeah, that might have caught some of you, especially if you've not done indices before, but it's cool. I'm going to show you a real cool way of thinking about indices, which will enable us to tame this beast. Okay, so let's take something like x to the power 5, which we know is 5 x's multiplied together. Now what we're going to do is, we're going to divide by x, like so. So we get x to the power 5 divided by x. Now as you can see, an x from the top will cancel with an x from the bottom. So we're left with essentially 4 x's multiplied together, which we know from indices laws can be written as x to the power 4. Now we're going to take x to the power 4 and do the exact same thing to it that we did to x to the power 5. We're going to divide by x. And when we do that, we're left with 3 x's multiplied together, which again from indices laws we know is x cubed. We do the same thing to x cubed. We divide by x, we're left with 2 x's multiplied together, that's x squared. Again, x squared divided by x, x's cancel, we're left with just 1x, which is x to the power 1. Now, here's where x to the power 0 comes in. We divide by x again, and anything divided by itself is just 1. So x to the power 1, or just x, divided by x equals 1. And we say that this is x to the power 0. The reason we do this is to stick with the convention, because as you can see we started with x to the power 5. We divided by x and we were left with 4 x's multiplied together, which is equal to x to the power 4. We divided by x again, we were left with 3 x's multiplied together, x cubed. We did it again, x squared, again, x to the power 1. So each time we divided by x, our power came down by 1. So, to stick with the convention, when we divided x to the power 1 by x, we call this new thing x to the power 0, which happens to equal 1, as we can see when we write it out longhand. So that's where x to the power 0 comes in. So it's not quite the same as what we've normally thought of it as, of x to the power 4 means we've got 4 x's all multiplied together. It doesn't sort of work that way. But I hope you can understand why it is equal to 1. It's just the way indices laws are, it's just the convention that mathematicians came up with in order to simplify things, and it just so happened that x to the power 0 equaled 1. So it's not something you should worry yourselves over, it's just something you've got to remember. The crucial thing is, and the biggest mistake people can make, is to say x to the power 0 equals 0, and that's just not the case. You've got to remember it's equal to 1. So I hope that made sense. Now, some of you might be thinking, well, do we need to stop there? Can we keep dividing by x, and if we do indices have a part to play? And the answer is yes, we can keep dividing by x. So we can take x to the power 0, or 1, and divide by x. And in the first case, we get 1 over x to the power 1. Now in this case, indices laws doesn't really simplify anything much, so we just refer to it as 1 over x. But if we divide by x again, we can rewrite that as 1 over x squared. Because in the denominator, we've got 2 x's multiplied together, we use indices laws and we say that's x squared, so we say 1 over x squared. Again, 1 over x cubed, and finally 1 over x to the power 4. So indices laws are useful if we're multiplying and if we're dividing. Now as it happens, even this 1 over an indice, we can rewrite in an even shorter form. The way we do that is that the indice comes to the top, and to signify that it's come to the top, the power becomes a negative power. So to illustrate that, 1 over x to the power 1 becomes x to the power minus 1. 1 over x squared becomes x to the power minus 2. Then we have x to the power minus 3 for 1 over x cubed, and x to the power minus 4 for 1 over x to the power 4. It's just an even shorter way of writing what we had before. All that happens is the indice moves from the denominator, moves up to the numerator, and to signify that change, the power becomes negative. And that's all there is to it. Now if you remember in the beginning of the video, I said I was going to give you 2 of the 5 indices laws. And as it happens, I've already given them to you, you just don't realise it yet. So if we have a look, here is the first 5 indices laws. I'm going to leave the first 3 blank because that's what we're going to cover in the next video. The 5th indices law is that x to the power naught equals 1. Now the x here isn't important. It could be anything, a, b, c, because the theory is exactly the same. If we had b cubed, we divide by b, we get b squared, divide by b again, b to the power 1, divide by b again, we'd get 1. So the x here isn't important. So x to the power naught equals 1. That's the 5th indice law. The next one is just what we've been doing. 1 over an indice is equal to the indice rewritten with the negative power. So 1 over x to the power a, where a is any number, equals x to the power minus a. And that's all there is to it, really. That's the 4th and the 5th indice law. If this has been a bit fast for you, don't worry. Feel free to go back and watch the bits that you didn't understand again, and you will understand the indices laws. It's nice and easy. You don't need to worry about it. The reason I've gone a little bit quick here is because I already assume you know it. Because you guys have come from GCSE, you should have covered this already. You should be masters of indices laws as it is, and so I've gone a little bit quicker. In the next few videos, as things start to get more heated, as things get more difficult, and the content just gets a bit more demanding, I will slow down. I'll talk a little bit slower, and I'll spend a lot more time explaining the principles behind everything. Whereas here, you guys already know it pretty much, so I've just gone a bit quick to save you from having to spend, I don't know, 20-30 minutes on indices laws on something you already know, so you can quickly move on into the things you don't know, and you can get the best benefit, the maximum benefit from your time. So, with that done, I'll leave you with this video. In the next video, we'll cover the remaining indices laws, and at the end, I'll give you a screenshot of a few exercises I want you guys to have a go on your own, and then I'll create a separate video where I go through the exercises one by one, and hopefully you guys will have aced it.